Engineer Ralph Tutorials, you're one idea away.
Popularly called Sir Muhammad. So you are welcome to the online tutorial class. Today we are going to start with physics 1210, popularly called mechanics, and we are going to start with what we refer to as quantities. There are two types of quantities. We have the derived quantities, and we have the fundamental quantities, and we have the derived quantities. The fundamental quantities are those quantities that are independent; they do not depend on anyone, while derived quantities are quantities that are dependent. So anything that is dependent is unlimited. Do you understand? For example, those of us that depend on government, we are too many. Do you understand? But the people in the government, they are not many. We can count them. So also, that's the same thing. Fundamental quantities can be counted because they are independent. We only have 7 fundamental quantities. But as for derived quantities, they are uncountable. And these fundamental quantities include length, time, temperature, electric current, light intensity, amount of substance, and also mass. All these quantities are fundamental. But if you want to talk about the derived quantity, an example is what? A velocity. Velocity is a derived quantity, and it depends on 2 fundamental quantities. That is length and time. That is why velocity is length over time, usually called as distance over time. While acceleration depends on a derived quantity and also a fundamental quantity. Acceleration depends on velocity and at the same time depend on time. This is the reason it's called velocity over time. Derived quantities are dependent quantities. So now, fundamental quantities, because they are limited because they do not depend on any other quantity, but derived quantities are unlimited because they depend on other quantities. For example, in a house, if I come and say, how many people do your father depend on, you can say he depend on his business. He depend on only one thing. But now if I ask you how many people depend on your father, you wouldn't know because there are too much. The same thing is applicable here. The fundamental quantity who depend on himself is limited. They are just 7, while the derived quantities are many. There are millions. So now the 7 fundamental quantities are mass, length, time, temperature, electric current, and light or luminous intensity. And the mass is measured in kilogram, length in meter, time in seconds, temperature in Kelvin, current in ampere, and electric current in candela. And also these are their units. So now let's see what happens to derived quantities. We say derived quantities are quantities that depend on other quantities. So let's take example 1, velocity. Velocity depends on length and time. So this is why velocity, the formula of velocity is distance over time, which is what is the unit for distance is meter, the unit for time is second, so combination meter over second. Anything over something means per, so that's why we call it meter per second. Now we talk about acceleration. Acceleration depends on 2 quantities, one fundamental and one derived. It depends on a derived quantity called velocity and a fundamental quantity called time. So now velocity is meter per second, time is second. So now we are going to have meter per second per another second. So since we are having per second, that is 2 per second. So that means it will be meter per second square. So now look at force. Force depends on a fundamental quantity and another derived quantity. The derived quantity here is acceleration, and the fundamental quantity here is mass. So combination of mass and acceleration gives us what? Force. And that means the unit of force will be kilogram time, which is mass, times meter per second square, which is acceleration. And now when we combine it, it will give us kilogram meter per second square. So usually this is not used. We use what we called Newton. This is because it was named after the founder of this particular force. But that is why they call it Newton. His name is Sir Isaac Newton. Now, the next quantity we are going to look at is area. Area is length times breadth. But length is also a length, breadth is also another length. So that means it is meter times meter, which is meter square. So the unit will be meter square. Also volume. Volume is length times breadth times height. But length is a length, breadth is a length, height is a length. So they are all meter times meter times meter, which will give us meter cube. So anywhere you see something carrying meter cube, it shows that that particular thing is volume. When it carries meter square, that means that particular thing is area. So now the next quantity we are going to look at is pressure. Pressure depends on force and area. That is two derived quantity. Force is a derived quantity, area is a derived quantity. Pressure depends on two derived quantities, which are force and area. What is force? We derive the unit of force at the back, we say is kilogram meter per second square. The unit of area we say is meter square. So now combining them, we have kilogram meter per second square over meter square. So this meter will cancel one of the meter here, so we have 1 meter remaining. So it will be kilogram. I told you whatever is down here is referred to as per. So it is now kilogram per meter, then this per second square comes in per second square. Or another way you can derive the unit of pressure is by saying, we said I told you that this one can be represented by Newton, naming it after the founder of force. So now Newton over meter square, which is area. Area is meter square, which now, since it is down, it will be per. Cool? So now it is Newton per meter square. So, but this one is also named after the founder of pressure, who is Blaise Pascal. So it is now called Pascal. Now another one is density. Density is mass over volume. It depends on fundamental quantity mass and derived quantity volume. So now we have kilogram per meter cube. That's it. Now the next is energy. Energy is simply force times distance. So force is kilogram meter per second square and distance is meter. Combine them together, kilogram is still here, meter times meter will give us meter square, then per second square is per second square. But it's also this unit, this particular unit is named after the person, the founder of energy, which is also, his name is Joule. Now the last one we are going to look at here now is power. Power is given by energy over time, and energy is Joule. So Joule per over second. So Joule over second, I told you anything that is down here is referred to as per, so it will now be Joule per second. Now next, what we are going to look at now is dimension. Dimension. What is dimension? Dimension is what we use to represent certain quantities. To represent what? Certain quantities. And this most of dimensions are referred to for fundamental quantities. But at our level now, we are going to look at only these four. But each of the fundamental quantities have their own dimension. But we are going to look at these ones for now. Mass has a unit kilogram. Its dimension is capital M. Length, the dimension is capital L. Time, the dimension is capital T. Temperature, the dimension is theta, and amount of substance dimension is mole. Now let's see for examples. What is the dimension of velocity? Velocity, we say it is what? Distance over time. What is the dimension of distance? Distance is a length, right? So the dimension is L. Is L. Per, what is the dimension for time? Is T. So it will be L per T. L per T, because I told you anything that is down is called per. Now acceleration. Acceleration is velocity over time. So what is the dimension of velocity? L per T. All over time. What is the dimension of time? Is T. So now when we put it, it will be L per T. This is per T. Then this one that is down is another per T. So it will be L per T per T. So if you join per T and per T, they will give us per T square. So this will give us L per T square. So now another one we are going to look at is force. Force is mass times acceleration. Mass times acceleration. So what is the dimension for mass? Capital M. What is the dimension for acceleration? L per t square. So now it will give us m L per t square. The next one is density. Density is mass over volume. The dimension for mass is capital M. The dimension for volume is L cube. So if you join it together, it will give you m per L cube. Now the last one we are going to look at here is pressure. What is pressure? Pressure is force over area. What is force? We say it's the dimension for force. We derive it at the back just now. We say it is what? ml per t square. And now we have L square down. This L will cancel one of the L here. So we are now going to have m. This L is down, it's not up, so it's going to be per L. Then this per t square comes as per t square. This is how you find dimension of little quantities. Now, why is this dimension so important in physics? There are certain reasons why dimension is very important in physics. So dimension is very important in physics because we can use it for several things such as correction of formula, derivation of expressions, and so on. So one of the importance is for correcting formulas. Dimension can be used to correct formulas if the to check whether a formula is correct or wrong. How do we check whether a formula is correct or wrong? Now let's see this formula. We have velocity is equal to distance over time. Velocity is equal to distance over time. So now let's check whether this formula is correct. What is the dimension for velocity? L per t. What is the dimension for distance? L. What is the dimension for time? T. Now let's combine it. L, this one will be, velocity is L per t square. This one will be L. The down here is per t, so it will be L per t. So L per t, that means this formula is correct. Now let's check the second one. The second one says velocity is equal to acceleration over time. If velocity is equal to acceleration over time, what is velocity? L per t. What is acceleration? L per t square. And what is time? L is t. So now combining it, velocity will be equals to acceleration, which is L per t square, all over time, which is t. So now it will be per t square and another per t. Per t square per t will now give us per t cube. So that means it will be L per t cube. So if you check, L per t square is not equal to L per t cube. That means this formula is incorrect. Now another very useful and very important aspect is dimension can be used to find a constant. For example, in a question like this, they are asked to, they say find the dimension of the constant a and b in this. Look at the expression. You are given p plus a n square over v square and v minus nb rt, where pressure, p is pressure, v is volume, n is number of moles.